How can you hack Alibaba Cloud's Kubernetes cluster? Well, we're going to show you how in this hacking episode with Ronan and Hilai, who are security researchers at Wiz. They have all kinds of skills when it comes to hacking vulnerabilities, which can happen due to lots of reasons. Among them, misconfigurations, which you'll hear about in this episode. They targeted a complex and feature-rich database, Postgres, and from there things got pretty interesting as they got access to a Kubernetes cluster. Let's check out the episode. All right, you guys, what are three emerging Kubernetes or other tools that you're keeping an eye on?
Me and Ronan we might know a lot about Kubernetes, but the funny thing is that we didn't really come from any Kubernetes backgrounds. We don't develop Kubernetes environments at all. We're kind of, regular hackers that went into Kubernetes hacking and not really Kubernetes people who went into hacking. So we're not familiar with a lot of Kubernetes tools, to be honest. Most of the Kubernetes tools that we're familiar with is stuff that we, found in our engagements, stuff that we were able to, to exploit in order to get ahead. So I think we're not the best people to ask about new Kubernetes tools, but we're very excited about, Kubernetes research, particularly.
Very good. Very good. What are three tools though that you're fans of?
I wouldn't say tools, but maybe like infrastructure, like stuff like service meshes. We are a big fan of that. Also, from attacker perspective, it's really nice to engage with now. And yeah, I don't know. We don't have any like great tools in mind right now.
That's okay. Now, for people who don't know, can you tell me a little bit about what you do? We understand it's related to hacking on that sort of stuff. What you do and where you work.
So me and Ronan work for Wiz, which is a cloud security company. And what we do particularly is we're from the vulnerability research team. What we do basically in our day to day is we go to major cloud services and major cloud service providers like Azure, GCP, AWS, et cetera, and we basically try to research those services through their open bug bounty programs and try to find any flaws that we can report and try to make the cloud community safer by doing that, not only for our customers but for the community in general, because we try to publish our findings for everyone to be able to protect themselves.
All right. And do you exclusively look at hacking cloud environments? And is this something that's typical for security researchers, or are you kind of in a niche?
So I think it's not at all typical, actually. I think all of us, me and Ronan and the rest of the team, we all come from backgrounds who are not cloud related at all. We were familiar with hacking before we were familiar with cloud environments. But I think that lots of the research that we do and other people in the cloud security community do try to evolve this the cloud security research forward, right? Finding new novel attack techniques and therefore making the cloud a little bit safer. That's what we try to do.
Does make it sound easy, but I don't imagine it is. In what way has your prior work focused on Kubernetes security? I mean, what have been some of the interesting things that you've discovered along the way, coming from an area that wasn't necessarily so Kubernetes focused, but coming with that hacking background? What are the things that you picked up throughout this journey?
So lots of cloud providers use Kubernetes as a way to, and container technology in general, in order to manage their services. Because if I'm a cloud company and I have hundreds of thousands and millions of customers, then I can't. It won't be economical for me to set up a new virtual machine or physical machine for each one. So containers were an amazing improvement at how big companies can manage their huge infrastructure. So lots of cloud environments are built on Kubernetes, and we were basically getting to Kubernetes because we were focused on cloud. We found Kubernetes in lots of the engagements that we did, not only in Alibaba Cloud, but in other places like IBM and lots of other companies. So we basically went into Kubernetes because it's widely used. We didn't start from Kubernetes and then get into cloud. But
yeah, but I think the start point was like container security, because we had many researchers where we did container security, and we tried for example, perform container escapes and find new vulnerabilities that might affect containers, more likely container escapes. So through that, we advanced to many other researchers, which fortunately have been using Kubernetes for their infrastructure. So through that, we got to the point where we had to like learn Kubernetes and find ourselves and basically invent those techniques um, to basically achieve what we're looking for.
And now to take it more on, your experience as working professionals, if you could go back in time and give, share one career tip with your younger self, what would it be?
To always, follow your curiosity. I think when you're doing research, it's always like following those leads and hunches and doing stuff that makes you curious. Like I think we were all, a little bit curious about cloud security because we were not from that field, and it started to, to emerge and to become this popular thing. And I think we all got here because we were curious, because we wanted to find out more and we wanted to get into this new thing that nobody's done before. So I would say definitely follow the curiosity.
I would. Yeah.
Okay. And also with that too, it is with that, curiosity following leads and also being researchers. What have been the best resources for you? Kubernetes ecosystem moves very quickly. Have you mostly got informed through blogs, through technical documentation, watching videos? What's worked best?
So for me, it was like pretty much documentation. Of course, there are many blogs that I've read from cloud providers and from like regular like CNCF blogs, which like actually contain really good information. And also, the Twitter ecosystem, specifically for Kubernetes, is highly active. So I get regular updates from there about new technologies and really about new features. So for me, it was that.
I agree with all that Ronen said, and I would also add Reddit. I'm a very big fan of Reddit. You have these all these communities, security focused communities, Kubernetes focused communities, cloud focused communities, and you get all this amazing content through there. I'm a big fan of Reddit for this.
Fantastic. Yeah. Also, in our case with the podcast, we've been seeing a lot of conversations on Reddit too, where people can really, deep dive, take it as far as they want. But then, as you mentioned, Ronan, about different resources as well, like Twitter, where a lot of conversations are happening, particularly in the Kubernetes ecosystem. It's definitely a good place to stay on top because, like I said, there's just a lot of things going on.
Yeah,
Um,
it's really
so
good.
yeah. So for today's conversation, in terms of our monthly content discovery, we came across an article about how you hacked Alibaba's cloud, Kubernetes, Alibaba Cloud's Kubernetes cluster. There was also a talk that you did in KubeCon. So you're here today because of hacking this Kubernetes cluster. This might sound a little bit strange to say out loud. And here you are on a Kubernetes podcast, speaking about it. So before we dive into the details, tell us why. Why would you do that? And this is something that your employer was okay with?
Yeah, our employer is absolutely okay with it. In fact, that's basically what we do at our employer. We always do cloud security related research, and oftentimes when you do this research, the we think the best methodology for doing it is being offensive security research. We try to act as attackers would act when trying to hack these environments, and then obviously once we find something interesting, we would report it to the vendor, and that way when you get like this attacker sort of mindset approach, we would prevent actual attackers who have bad intentions from doing the same thing. So this is what we do at Wiz, and this is one of the engagements that we did with one of many different cloud providers and services.
And of course, like through those researches, like we always find some new techniques maybe that we've never seen before. Haven't been published. So we always look how to basically allow the community to see those techniques and actually understand how they can protect themselves from those techniques.
That's great. And one of our previous guests, sorry, this is an unscripted question,
Yeah.
but I just want to take advantage. One of our previous guests, he talked about, Kubernetes secrets management, and he also talked about threat modeling. And the thing that comes in there, right, is like, how do you put yourselves in the mind of the bad, the bad hacker that's out there that's going to try to exploit, some kind of weakness? Is this something that you do on a regular basis that you're just sitting having lunch and you're like, if I had to hack this, restaurant, how would I do this? How do you make that like a regular practice? How do you go about sort of, almost, I don't want to say empathizing with bad hackers that might be out there, but to really think about their thought processes and how they're approaching, how they view a system and how it can be exploited?
Yeah. So I think most of our views on that like come from the actual experience from those researchers. So basically, when we engage with some application, when we engage with some framework or cloud provider infrastructure, so we see those kind of mistakes. Like we usually try to poke around and find those critical mistakes, find those little things that people might overlook. Um, and from there, we try to understand the whole flow, like how this could have been prevented.
Yeah, and I would add an interesting point about that when you're doing cloud security research is, a lot of the times in traditional security research, when you're researching into an application, what you want to achieve is RCE, remote code execution. You want to execute code on the machine, but in cloud security, because it's so a wildly different world, remote code execution is often, intuitive. You get a machine and you can execute your own code on it. So what's interesting to find? So what we try to find a lot of the times when doing cloud security research is breaching barriers between different customers, because this is the problem of the cloud. This is the unique problem of the cloud, because you share your environment with all the hundreds of thousands of different customers such as yourself. You want to try to prove, obviously without actually accessing any data, but to prove that you were able to access other customers' data, to breach that sort of trust that the cloud gives you. So this is what we oftentimes do in cloud, which is not traditional in security research.
And with that in mind, when starting out this journey in this particular case, how and why did you end up deciding, all right, we're going for Alibaba Cloud? What made that the fit for this particular exercise?
We've actually started with the Postgres SQL research. So we understood that like many cloud providers allows you to use Postgres on your a managed Postgres, basically a managed offering that they started to give you an option basically to use. And we wanted to explore it further, like to see how cloud providers managed those infrastructure like behind the scenes. So we actually started to perform a research across cloud providers. So we found like many vulnerabilities that basically allowed us to execute code on cloud provider managed PostgreSQL instances. And we also did a Black Hat talk about it. We tested basically big cloud providers to see if they were vulnerable to the actual exploits we found. And through that, we actually also managed to test Alibaba and perform the research there. Do you want to add something?
Yeah. As Ronan said, basically it started from Kubernetes, and from that it became Alibaba, but it also became a lot of different other cloud providers. And if anyone is interested in checking out some of the other researchers, because everything is a little bit different, although they're all PostgreSQL, then I would highly recommend both the blog that we did about PostgreSQL and the Black Hat talk that Ronan mentioned.
Yeah, we also had a similar engagement that the start point was Postgres about IBM. So we have many links on our blog, so
Okay.
more than welcome to check it out.
Just curious, because in my experience, hearing a lot about Postgres, battle tested, old school database, going back for a long time, very strong community behind it. Were there, just for the Postgres fans that are out there that might be worried, like, oh no, they're going to say that Postgres is weak or easy to exploit? Was that wasn't really it wasn't part of the criteria. It's not like, oh, we were evaluating this against MySQL or MongoDB.
No.
So what was the decision process like there?
So I think Postgres is a really feature-rich database. So you basically can do a lot of things with that, which is great overall, but it also have many features which allows you to execute code on your database. Now, with cloud providers adapted this model to their cloud infrastructure, of course, they try to prevent you, a regular user, to achieve code execution on their managed instance, and also prevent you to gain system account permissions on your databases. So we basically try to bypass those restrictions and find our way to actually execute code on the managed database. So it's not like the Postgres SQL project itself had those vulnerabilities. We actually exploited the modifications cloud providers did to their PostgreSQL engine to allow certain features.
Now, to take this further, because I did spend a significant period of my cloud native life doing lots and lots of content around writing stateful workloads on Kubernetes. So, what is PostgreSQL's relationship to Kubernetes? Because I thought that you had gained access to a Kubernetes cluster and not just PostgreSQL.
Essentially, like we said before, when you do these, huge offerings for many customers, whether they're PostgreSQL or anything else that cloud provider provides, then because it's managed infrastructure, because it's the cloud is giving it to you and to many other customers, then oftentimes the most convenient way for a cloud provider to manage this is with containers, specifically with Kubernetes. That's the way for the cloud provider, in this case Alibaba, to offer PostgreSQL in a very convenient and quick way to any customer that wants to spawn it. So that's the way they manage it internally. To you as a user, it's supposed to be completely transparent. You're not supposed to know that your PostgreSQL instance runs on this and that infrastructure. It's just a Postgres instance, and you use it, and you're not supposed to know what's actually behind the scenes. But when we were able to basically execute code on that PostgreSQL instance using the flaws that Ronen just talked about, then we were able to start to sniff around and figure out that we were on a Kubernetes environment. But on like the default installation that the cloud provider is giving you, you're not supposed to even know what sort of infrastructure it's running. It's just very convenient for the cloud provider to manage it like that.
And we've seen many cases that the actual infrastructure behind the scenes wasn't Kubernetes. Like Alibaba chose to use Kubernetes, IBM chose to use Kubernetes, but there are many cloud providers that had their own implementation behind the scenes.
Got it. Now, one of the things that we hear a lot, in terms of security mindset and, avoiding vulnerabilities that can be related to misconfigurations, often which relate to human error. What were the main misconfigurations that you saw there that were leading to vulnerabilities?
So in this case, I think the main misconfigurations that we found is first of all, like the big overarching issue we think is that containers shouldn't be considered as a security barrier, and definitely not the sole security barrier. Like it can be a security barrier as part of your entire isolation environment, but containers by themselves are not strong enough to separate me, the Hilai customer, from the Ronen customer to the Bart customer, which are supposedly three different companies that aren't supposed to know anything about each other. So we think containers are not strong enough to do this because, first of all, every time there's a kernel vulnerability in Linux, which is not something that rare, that immediately bypasses every protection because the kernel is the thing that's supposed to be governing this. And second of all, is misconfigurations are very rampant, like the misconfiguration that we were able to exploit in this particular research. So we would not recommend containers as security barriers. Other flaws that we found here are very strong secrets that are within the environment. Within this Kubernetes environment was a secret that not only allowed overarching read access, but also write access, meaning that we are able to overwrite packages that would be distributed to lots of different cloud services and cloud customers in Alibaba. So that's the thing about, when you're creating these strong secrets, you can allow a person to travel between, different environments, different services, different customers, all through one secret. So that's definitely something that we would not recommend people to do.
Yeah, so to add to Eli's point, so I think the secret he's talking about is the image pool secret, which is a really core concept in Kubernetes. Basically, when you want to pull images from a private container registry, so you have to use this image pool secret basically to configure your registry credentials. So if you don't configure it correctly, you might put a key which has push permissions, and that's wrong because this key basically should have only pull permissions. And if attacker gains access like we managed to get in Alibaba, this can be devastating for your environment.
Okay. I think also too for a lot of people that don't necessarily have a strong security background, they might assume that, all right, security experts like the two of you come in, you click a button, it scans and it finds these vulnerabilities. But I think perhaps in the security world, like a lot of other worlds, it's a combination of art and science. Can you talk about the creativity that might be necessary there to find vulnerabilities on, misconfigurations, whether it's related to permissions, namespaces, things of that nature?
Yeah, so I definitely agree. Like, there's a lot of creativity to security research that oftentimes when you read about like a novel new attack vector that somebody finds, it's a lot of the time just creativity, just thinking of something that nobody else has thought of before. So I think in this particular research, when we try to when we started this research and started to look for these patterns of things that we were already knew were dangerous things, like high permissions and shared volumes, et cetera, and we didn't find them, that was a moment of, okay, we should stop and think, because we're not, we like hit this wall, we couldn't find anything interesting within the container, so we had to think outside the box here, right? Like, what else can we do that can make this container do something interesting? So at this point, basically, we went out of the container, out of the code execution that we were able to find, and went back to the control panel that that Alibaba Cloud gave us, and started clicking on all the buttons that we could find to try to make something interesting happen. And this was like one of the big breakthroughs in this research. We found this button that enabled SSL encryption for the PostgreSQL instance. And once we clicked that button, lots of interesting stuff started happening within the container that we were able to like follow. Oh, stuff is happening. There's new stuff that we haven't seen before. Let's follow that lead, and that was the lead that we managed to escape the container with. So I think, like you said, it's a lot of times it's just creativity. We try all these patterns that are well-known patterns, and none of them, all of them fail. None of them were actually misconfigured like that. So we have to, let's get out and try to find new features, find new buttons, find new something that we can do. This is what basically led this research to success, to container escape.
And with that in mind, so at this point, then moving forward, you get to something that to inform our audience. What is SCP, and what role did the SCP command play in the attack, and how was it exploited?
So SCP is a file transfer utility that's in every Linux box. Basically, it uses SSH connections in order to transfer file between machines. And in this particular case, the SSL encryption feature that we were able to click, and SSL encryption, the way that it worked is there was a new container, an Alibaba management container, and it ran the SCP command on our container in order to basically move the SSL certificate from here to there. So what we're able to exploit here basically is that the SCP command read its configuration by default from a directory that we were able to control. So we basically added, our own malicious configuration, an SSH configuration that, when loaded, would run a command. And that way we were able to get from our container, which was a weak container, to a new container, to the Alibaba management container, because it took the command from us and it ran it in there. So that way we were basically able to skip from here to there, which was nice. It's a nice little trick. Yeah.
One of the most critical points that we had there, that the shared volume basically was a shared home directory. Basically, we had the same user in our container and the management container. So we shared the home directory. So SCP by default reads your configuration from your home directory. So by changing this file to a malicious file with our command, and because of it was shared between the management container and our container, so we actually could exploit this.
And what does the success of creating a privileged container via the Docker API signify about cloud security more broadly?
Many Kubernetes environments use Docker as their container management component. So when you manage to get access to the Docker API socket, or for example through an HTTP request, you can basically spawn a new container, possibly a privileged container, which will share many namespaces and possibly also volumes with your host. The host is the actual Kubernetes node. So if you spawn a privileged container with all those components, you basically achieve node access, Kubernetes node access, allowing you to access all the things basically that the node has access to.
Basically, from the guest to the host,
Yeah.
from the pod to the node.
And what was the next step when you gained access to the underlying Kubernetes node? Because you shouldn't give you access to the entire cluster necessarily, but only a limited view, right?
Yeah. So basically, of course, now that you have a code execution on the node, you can use the kubelet credentials to basically start to poke around, maybe to use the commands get pods, get secrets, and all those stuff. But on the default Kubernetes, you shouldn't have access to those to all those resources. Let's say Alibaba configured their kubelet credentials that it will have those permissions. So using the kubelet service account, we managed to get a broad access to the whole cluster. So we could list all the pods in the cluster, which contained customer information. And also we could use the get secret to actually get all secrets from the whole cluster. So this was a really big misconfiguration that we could use to see all those resources.
And this is all still on a single node, correct?
So yeah, so we were running on a single node, and we used our kubelet kubelet credentials to basically see. We could have seen all the other nodes in the cluster and their resources as well.
Like although that node was separated from other customers, like although that node only belonged to us and did not contain any of the customer data, that node's service account, the kubelet account, was too powerful. Although that specific node was isolated, its service account was able to access all these, all this crazy informations and pods and nodes and secrets that were other customers' data.
Exactly. Yeah.
All right. So you took over managed PostgreSQL offering at Alibaba. What happens next? You call up Alibaba and say, "Hey, we got a story to tell you." Or do you start using free Postgres for your personal projects? What was the next step after that?
So definitely not using the free Postgres. Every time that we, at this point in any research where we can prove that we're able to access other customers' data, then definitely game over. We don't want to get into a situation where we accidentally view other customers' data. So at this point, we gather everything that we found. We send a report to Alibaba Cloud, and they responded. The Alibaba Cloud security team responded very quickly, very professionally. We were able to, find. They updated us on all the fixes that we're able to deploy in order to fix all the problems along the research pipeline. So yeah, definitely everything that we find that we deem like a critical issue, we report immediately, so that other people can't exploit it for other purposes.
Did they send you any swag to say thanks, or did they? Maybe not so much that, but did they? Can you tell me about any of the fixes they may have implemented to address the issues that you brought to their attention?
Yeah, so we found actually a couple of big mistakes which we had them fix. Of course, the first one was the actually Postgres issues that we found that we used to exploit to execute code on our instance. So we worked with them closely to help them fix them. Secondly, they fixed the problem, for example, the SCP problem, which basically allowed us to hop from our container to their management container. So they fixed that. Also, they restricted the kubelet permissions to only scoped ones and not broad ones like they had. And they limited the image pool secret permissions to have only read access and not push access like we managed to prove we had.
Like that's like the entire flow of the research. Every flaw that we were able to find along the way was fixed separately. And in addition to that, they actually also implemented some sort of safe container technology developed internally in Alibaba. Similar to Google has the gvisor project, which is open source, sort of container hardening technology that makes a container hard to escape to, more hardened configurations for the container. So they also implemented that as an additional safeguard, in addition to all the issues that we found.
Okay, so throughout all this process, what would you say were the key lessons that were learned?
So first of all, like we said, the containers are not a strong enough security barrier. It can be bypassed in a myriad of different ways, and obviously, every security barrier can theoretically be breached. But we feel like containers are not a high enough bar for breaches and for isolation between customers. So we feel like the container should never be the sole security barrier. It can be a security barrier, but there have to be additional safeguards in place, what people like to call defense in depth, in order to make sure that a singular vulnerability won't be something that separates my company from my competitor company, from accessing the data of my competitor company. So that's one thing. The second thing is the management of strong credentials. Like Ronan said, in this case, Alibaba had originally had a very strong secret that was able to read and write data from all across the environment, to an image pool secret that was able to push new Docker images to the central registry and spread to all these other cloud services in Alibaba. So and then following a report, they scoped those credentials so that they won't be that strong. So we would advise to be very, very careful around strong secret like this. Hopefully not even have them at all, and have each strong secret scoped to a specific action. But when you have a strong secret like that, you can help people to basically hop between environments, hop between production environments to development environments, hop between testing environments to development workstations, etc., etc. And also, in terms of the container itself, the first vulnerability, the SCP vulnerability, another lesson here is the namespace sharing between containers. Like in this case, Alibaba spawned a new container that interfered with our container, a container that is customer container, so it shouldn't really be trusted. And it had a shared namespace. It had a shared home directory, which you were able to exploit using the SCP trick. So we would advise, whenever you share namespaces between your own trusted container and the customer's non-trusted container, to do it very, very carefully, to be extra safe about everything that you share, and never give any extra permissions unless it's absolutely necessary. Because every sort of lenient misconfiguration that you do can be potentially exploited by attackers.
And for people in our audience, that may want to have a further conversation with their boss, if the subject of which tooling should we keep in mind? I know we talked about this in the beginning about, which tools are catching your attention, but to implement some of these, these tactics, these things that need to be kept in mind, is there anything that you would recommend that people may not be aware of?
Yeah, so obviously there's lots of different tools. I'm sure there are even tools that we're not aware of that are doing a great job, because there is a very active Kubernetes community. What we can highly recommend is a framework called Peach. That basically, it's an open source project that we developed at Wiz. Threat research team at Wiz developed. It's completely open source, and it's made possible because of contributions from lots of wonderful people from lots of great companies. Basically, it's a framework for how to build an isolated environment in the cloud, or not in the cloud, in order to truly make defense in depth when you're serving things to different tenants, different customers, and you want to isolate them properly. It's basically like a white paper sort of resource on how to do this thing correctly. What sort of mistakes should you be aware of? What sort of things you should be on the lookout for, and how to correctly implement those sort of safeguards. So we highly recommend to check it out. It's, I think, peach.wiz.io, and it's also on GitHub. So I highly recommend to check it out if you have, your own multi-tenant environment, your own environments that you want to isolate things from each other. It's a great resource, and if and if anyone listening to this knows any tricks or tips that we don't, then contributions are also greatly appreciated.
Yeah, I would also recommend some secret scanning tools. Right. In all of our researches, we usually perform a secret scan on our machine, on the cloud infrastructure. So we always find some secrets through that. So environment hygiene is really important, especially in managed environments. So there are many good tools for secret scanning. So we highly recommend anyone to use that to make their environment safer.
And since the subject of multi-tenancy came up, the attack that you're describing today, for our audience, originated from a common practice of sharing a Kubernetes cluster with multiple tenants. Given the gravity of the flaw and its potential consequences, is there any recommendation for securing multi-tenant clusters in Kubernetes that you'd like to share?
Yeah, so I think the most important thing when implementing multi-tenancy in Kubernetes, I think we can separate it in a couple of things. First is network security. By default, Kubernetes doesn't let you or doesn't prevent you from accessing different pods, nodes through a network. So implementing a good network isolation is a must. Secondly, if you already talking about multi-tenancy, so separating namespaces between customers can be a good approach. Implementing good container security technologies, like for example gvisor or Kata containers, and not relying on the sole security of, for example, Docker, to prevent like container escapes. I think it's a good approach. And yeah, I think those are the key points I would focus on.
Particularly with the part about containers, in terms of hardening containers so they're more difficult to escape,
Yeah.
any recommendations, advice you give there?
I can give you an example. For example, from the Alibaba research, they had Linux namespaces shared between containers. For example, from our management container and our container. So when you design a system that you share namespaces or share like resources between management containers and regular user containers, you always have to assess those risks and be aware of them. So sharing Linux namespaces can be dangerous, yeah, but also using container technologies like we mentioned, like gvisor and Kata containers, can potentially prevent you, for example, from Linux kernel vulnerabilities that attackers might exploit in your environment to achieve, for example, kernel level code execution, basically allowing you to hop to the Kubernetes node.
Question that I want to ask here, for a lot of our audience that might not have such a strong security background, a question that comes up often around this nowadays is like, is everyone a security stakeholder? Are there certain things that just can't be overlooked by any Kubernetes engineer because of the environments in which they're going to be working, the risk, the danger? Is it just hyper paranoia? What do you think about that? Is security that something that should be siloed? It should be, shared across an organization. Is this something that people really need to make sure is available in their tool belt? What sort of advice would you give for regular Kubernetes engineers that are out there that may not have so much contact with this area?
So I think that security is super important. Like I don't have to. You only have to open the news these days in order to find out the sort of flaws that everything from small startups to huge corporations can fall victim to these, to the actual bad guys, and not just white hat security researchers almost every day or every week. And you have to, what people I think have to understand is that when you're creating this service, this thing that is on the internet, that it immediately becomes a target to all these sorts of actors in the cybersecurity space, whether they are white hat hackers that are looking to make a world a better place, or people that do ransomware, do data stealing, do all these sorts of things. So I think that even the smallest of projects doesn't have the luxury of not caring about security. But that's on the the maybe the bad side. But on the good side is that there are a lot of tools today that help people to achieve these goals without doing a lot of manual work. Tools like gvisor that Ronen mentioned, which is a project by Google to harden containers, is stuff that is not extremely hard to implement because you don't have to write it yourself. And just by implementing these sort of things, you get all this added protection. So I think that people should be interested in that. Every sort of project, community, company should be interested in having their things secure from external attackers. But the good thing is that there are a lot of good tools in order to help you be secure.
Yeah, I think it's not only tools, but like a lot of resources online which you can read about.
documentation.
Documentation,
Blogs.
like blogs, which can actually help you understand those risks and help you protect them. I mean, Kubernetes by itself has a lot of many good features, security, for example, the pod security policy, and many other things. So yeah, I mean, we encourage people to be aware of security in general and make their environment secure.
Fantastic. You in this case, you discover this vulnerability, this problem, and you notified Alibaba. But what's stopping you from, not joining the dark side and be like, I'm aware of this vulnerability and I'm not going to let them know about it? Do you think that Alibaba would eventually caught on?
Yeah, I'm pretty sure, because like I think right in the middle of our research, they already started taking steps which they told us. So I think every cloud provider has have their security teams on it. Like so they always monitoring their environments. They know you're there. I think cloud providers are doing a great job. And from our side, we are white hat hackers. So we, of course, our goal is to always, make
the community more secure, make the cloud more secure.
Exactly. So
the offensive research is just a tool in order to do that. We want those vulnerabilities to be fixed. We love hearing, when we report something, that a new product update was launched to many customers that helped them be more secure. This is the stuff that this is the reason that we're doing this, basically, is both to, help these products be more secure, and two, to help customers learn how to secure their offerings, right? Like when people, that's why we publish these blogs, these talks, so that practitioners from the defender and the developer side can see these things, oh, that's actually a mistake that I can also be making on my own environment. So this is basically the reason that we're doing this.
Very good. That being said, what's next for the two of you? Who are you going to attack next?
So we can't tell, but but we constantly work on new stuff. We recently published a blog about actually Hugging Face, the AI provider by Sagi from the team that is not here at the moment. But we are constantly working on new things. There are a lot of researchers that are currently, on the disclosure that we can't, disclose until everything is fixed. So definitely keep an eye on our blog. That's where we post. This is the first place that we post where something interesting drops. But we definitely have good stuff in the oven. So stay tuned.
And of course, from those resources, many Kubernetes resources will also come. So yeah.
Hugging Face, by the way, definitely a Kubernetes researcher. If anyone wants to read something that is actually news, actually very new, highly recommend the Hugging Face blog.
Very good. And if people want to get in touch with you, what's the best way to do so?
So we're all on Twitter. My @ is @Hillai, HILLAI,
and mine is Ronen, SHH. So yeah.
So we're definitely very on Twitter. You can DM us anytime, and you can also email us to the team at research@wiz.io. But I think Twitter is the place where we look the most.
Fantastic. Well, I'm sure people will be getting in touch with you about this. It's one thing to do it, but how you share your experience so eloquently and getting into all the details that, like you said, for a lot of Kubernetes practitioners simply aren't aware. They might come from one background or another, but not assuming that this is going to become part of their daily lives. Well, guess what? It's 2024 and it very much is. Like you said, all we need to do is read the news to know about that. So thank you for the work that you're doing. I think it is a very valuable service to the community, even though some of it may be behind the scenes. And I think it's your job so that it doesn't become a problem that's exploding, right in front of somebody, but rather something that can be maintained in conversations directly with cloud providers, as you've done with Alibaba. So yeah, thank you very much.
Thank you.
Wonderful having you, and look forward to seeing you whether it's in KubeCon or online. But yeah, take care, you guys. Cheers.
You too.
Bye. Thank you.
Bye-bye.